Hello everyone. Now we will see how to write a program of, of circular queue in C. So suppose we have a queue. Here we have some elements in a queue. So suppose we have 20, 30, 40, 50, 60 and 70. So now if we have two variables, front now is first pointing to -1. Now rear here is pointing to this index. Suppose this is 0, 1, 2, 3, 4 and 5. So rear will be 5. Now suppose I am removing 20, then front will be incremented to 0. We are removing this one and this one. So now front will be pointing to say now will be +1, that is it will become 1, then it will +1, then it will become 2, then it will become +1, it will become 3. So now the front will be pointing to the third index. Now if we see, we cannot add more elements to this queue as there is no more space at rear end, but there are some empty spaces at the front, but still we could not add because as per the rule the elements get added at the rear end only. So what is the solution? Now the solution is to have a circular queue. In the circular queue we arrange the elements in such a way that they appear like a circle. So let me draw a circle here. So this is my circle and this is the inner circle. Suppose I have 0, 1, 2, 3 and 4. So I have say 5 elements here and I have say 20. So suppose initially my front equals to -1 and my rear also equals to -1. Now when I add one element, the rear is incremented to 0, the front is also incremented to 0. So if the front is -1, it is incremented to 0, but in generally always when we keep on adding the elements, the rear will is going to be increased. Rear will be rear +1. So it is going to be 0 plus 1, which is 1. Now suppose I keep on adding now further elements, say 40, 50 and 60. Now the value of rear becomes 4. Now when I add one more element, I cannot add one more element now since it is full now. So the condition for the overflow is when front is equal to 0 and rear is equal to n minus 1. So in that case it will be an overflow. And now when we delete this one, then the front index is increased to 1. Now we have some empty space here, and if we want we can insert one more item also here. Now here when we add one more item, say 12, the rear we want to increase and it becomes 5. Now there is it is now 0 index. We do not have any 5 and 5th index here. So how we'll get 0? Now we will perform the modulus function. Say rear is equal to rear plus 1 mod n, where n is the size. So by this we can get 0. So how, like, it is becomes 5 mod 5, and 5 mod 5 we know is 0. So in this way we can get the corresponding index in a circular queue. Now let us go to the program. Now we have defined the total number of elements, suppose by n, suppose we have initialized to 5, and we have defined these global variables q, front and rear variables. So here also we will go in a loop to get the operations performed in a queue. We will ask the user to perform these operations, and if he wants to perform more operations, he can perform, provided he enters the test value as 1. Otherwise he will exit the performing any operation. Now let us go NQ, DQ and display. Now let us see how the inserting of an element happens in a circular queue. Now here this statement, it is asking for the item to be inserted. Now here, for checking the overflow condition, now one condition we have checked when front equals to 0 and rear equals to n minus 1. Now another condition is front equals to rear plus 1 mod n. What that means is, when suppose here, suppose now my front is pointing to, now my front is pointing to 1 and rear is pointing to 0. Now also in this condition also the queue is full. So here we can say the rear is equal to or we can say rear is equal to front minus 1, or we can say uh, the front, or we can say front is equal to rear plus 1, and we can say rear is equal to front minus 1, or we can say front equals to rear plus 1, that is mod n, rear plus 1 mod n. So if I write it again, it looks like this. So front is equal to rear plus 1 mod n. So this is when the circular queue becomes full. So this is the overflow condition. And another condition we have checked when front equals to 0 and rear equals to n minus 1. So both these conditions, this one and this one, if they hold true, then there is a overflow. That means the queue is full and we cannot add more items. So in the NQ, we first test the overflow condition. Then we do, if front equals to minus 1, we assign 0 to it. Then we increment 1 to rear. Each time we add some element or item to the queue, we have to increment the rear. Next we will see the DQ operation. In case of DQ, we have to check the underflow. First of all, when will this happen, underflow? Underflow means we have not our queue is empty initially. For example, when we did not add any more elements here in this particular queue or circular queue, then front was initially minus 1. When we did not add any more elements,